Thanks for checking out this video. I hope it's helpful as you study for Monday's exam. Make sure you have your study guide completed. Try these problems again. Go back into your binder and check out some of the problems that you've already done and try them again. Feel free to skip through this video to the sections that you need. Okay, let's get started. So in number 1, I'm going to have to combine like terms. Like terms have the same variable and the same exponent. So let's start with this 5z. I notice that nothing else has z, so I'll move on to this -4. I know that that is a constant and it goes with a +5. And finally I have +2y take away 8y, which are like terms, right in the center. So 5z is coming down because nothing can be combined with it. -4 plus 5 gives me a +1, so that will come down. And 2y take away 8y gives me a -6y. And none of those are like terms, so this is my final answer. Here's number 2. I notice that -3 is on the outside of parentheses, so that tells me that I'm going to distribute or multiply that -3 with everything that's on the inside. So I'm multiplying -3 with 5x, and I'm multiplying -3 with -10. And when I simplify, I get -15x plus 30. Those are not like terms, so that is my final answer. 3. I notice that, again, I have a -4 outside of parentheses, so that tells me that I am going to have to distribute that -4 to the x and then -4 to the 11. So let's set it up. -4 times x and then -4 times 11. And then this +7x here is on the outside of parentheses, so I am going to just bring it down. It does not get multiplied. Now, -4 times x is -4x, -4 times 11 is -44, and then I'm going to bring down my 7x. Before I end this, I got to look for like terms, and I found them here. -4x plus 7x gives me 3x, and this -44 comes down. That's my final answer because I cannot combine any further. Let's move on to Now I have a longer algebraic expression here, but I can still handle it. I'm looking for like terms that have the same variable and the same exponent. So if we start with 2x squared, I notice that I have a +9x squared. Those belong together. I have a +3x, and that goes with a +12x. And finally, I've got this -1y right there by itself. So I'm going to go ahead and combine my 2x squared plus 9x squared and my +3x plus 12x, and finally my -1y. Put in that one because it's helpful sometimes. So 2 plus 9 is 11x squared. Remember, we're just working with coefficients. And then 3x plus 12x gives me a +15x, and that -1y comes down, and that is my final answer. Now number 5 is different because this is an equation. It has an equal sign. So I am going to work to get y by itself using inverse operations. So I'm going to draw my river, and I'm going to circle the piece with my variable, which is the -7y. Now when we solve equations, we always got to get rid of my plus or my minus first. And then I have to do the inverse of multiplication or division second. So in this case, I got to get rid of a -3. The inverse of that is +3, and if I do it to one side, I got to do it to the other. These -3 and +3 cancels out. I'm left with -7y is equal to 14. And now I have to do the inverse of multiplying by 7, which is dividing by 7. -7, in fact. Let's not forget our signs. We never flip them when we multiply or divide. So I'm dividing the left and the right by -7. -7 divided by -7 gives us 1, so I'm left with 1y is equal to 14 divided by 7 is -2. And to check my answer, I won't check all of these, but I'll do a few just so that you have them for reference. I'm going to rewrite my original equation, which is negative 7y. Take away 3 is equal to 11. And wherever I see y, I'm plugging in my answer, which is negative 2. Negative 7 times negative 2, we always use parentheses, minus 3, and I want to know if that gives me 11. So negative 7 times negative 2 is 14, and 14 take away 3 is 11, and 11 is equal to 11, so I know that I am correct. This is the step that shows you finished your check, when one side is equal to the other. All right, let's move on to the next one. Okay, so here I have another equation where there is a number outside of parentheses that tells me that I am going to have to distribute. 7 times x is 7x, 7 times negative 2 is negative 14 is equal to 21, and now I've got to work to get 7x by itself. I'm going to draw my river, circle my 7x, got to get rid of negative 14. The inverse of that is positive 14, and if I do that to the left, I've got to do that to the right. Now these cancel out. I'm left with 7x is equal to 35, and I've got to do the opposite of multiplying by 7, which is to divide by 7, and I've got to do that to both sides. 7 divided by 7 cancels out, so I'm left with x is equal to 35 divided by 7, which is 5, and that is my final answer. Now to check that, I'm going to rewrite my equation. 7x take away 2 is equal to 21. And whenever I see x, I'm going to substitute 5. So 7 parentheses 5 take away 2, and I want to know if that equals 21. Now 5 take away 2 is 3, and 3 times 5 is, 3 times 7 is 21, and 21 is equal to 21, so I know that I am correct. This is the final step of a check. Okay, now let's move on to the Here I have another equation where I don't have parentheses, so that means I can't distribute, but I can combine like terms. I notice that I have a positive 2x and a positive 3x, so 2x plus 3x is 5x, and I'm going to bring down my minus 6 is equal to 29. You could have put that negative 6 first, and that would have been fine. If you wrote negative 6 plus 5x is equal to 29, that would have been fine too. I'll leave that up there. All right, so I'm going to draw my river. I've got to work to get 5x by itself. I've got to do the inverse of a negative 6, which is positive 6. And if I do it to one side, I do it to the other. These 6's cancel out. 5x is equal to 29 plus 6 is 35. Now finally I've got to do the inverse of multiplying by 5, which is to divide both sides by 5, and x is equal to 7. That is my final answer. Now if I were going to check this, I would rewrite, which is negative 6 plus 2x plus 3x is equal to 29. Oops, let's bring that guy back. And now I am replacing negative 6 plus 2 times 7 plus 3 times 7, and I want to know if that equals to 29. And that is what you would do. We would simplify. 2 times 7 is 14. Plus 3 times 7 is 21, and I would have a negative 6 here to bring down. And then if I do all of this math, that equals 29, and 29 is equal to 29, so I know my answer is correct. All right, let's move on to our next. All right, in this situation, when I draw my river, I notice that I have a variable on the left and I have a variable on the right, and when that happens I cannot simply combine like terms. I've got to get my variables on one side and my constants on the other. So if I want my variables on the left side, I like my 4m there, but I don't like my 7m, so I'm going to do the inverse of positive 7m, which is to take away 7m, and if I do it on this side I've got to do it to the left. 4m take away 7m is negative 3m. I'm bringing down my 3 is equal to, those cancel out, and I'm left with 6 on the right side. Now, if I go back to this negative 3m, I'm going to work to get that by itself. So I've got to get rid of this negative 3. So the opposite of negative 3 is a positive 3, and if I do it to the left, I do it to the right. I'm going to cancel these guys out. I'm left with negative 3m is equal to 6 plus 3 is 9. Finally, the opposite of multiplying by a negative 3 is to divide by a negative 3. That happens to both sides always. So negative 3 divided by negative 3 cancels out. I'm left with 1m is equal to 9 divided by negative 3 is negative 3. And that is my final answer. Now you could have done this differently. You could have wanted to subtract 4m from the from both sides in the first step. You could have added 3 to both sides as your first step, or you could have subtracted 6 from both sides as your first step, and you would still get m is equal to negative 3. All right, let's take a look at this problem, number 9. So this is a little bit more complex, but I'm going to just go through my checklist. So I know I have to distribute if possible, and it's clear that I do because this negative 3 is on the outside of parentheses. So negative 3 times n gives me negative 3m. Negative 3 times 5 gives me negative 15, and I'm going to bring down the other side. Alright, so I'm going to draw my river, and I notice once again that I've got m on the left and I've got m on the right, and I don't want that. I want my variables all on one side. So in this case, I want them all on my left side again. It doesn't matter which side you choose though. So my negative 3m is good. I'm going to get rid of this negative 8m by adding 8m because that's the inverse operation, and I'll do that to both sides. Now negative 3m plus 8m is 5m. I'm going to bring down negative 15 is equal to negative 15. These guys cancel out. Now I want to get 5m by itself. So what I'm going to do is add 15 to both sides because that is the inverse of this negative 15. Now let's simplify. These guys cancel out. I'm left with 5m is equal to negative 15 plus 15. Again, cancels out because it gives me 0. So I'm going to write 0 there. I'm not going to leave it blank. And that's okay. Now I'm going to go back here, and I got to do the opposite of multiplying by 5, which is dividing by 5. I've got to do it to both sides. 5 divided by 5 cancels out, and I'm left with m is equal to 0. 0 divided by 5 is 0, and that is my final answer. Let's look at number 10. So here's a problem where, again, I've got to look for the distributive property. I notice that the 7 has to go to the n and the 9. So 7 times n is 7n. Oops. Let's fix that. 7n. And 7 times 9 is positive. Let's fix this. Alright, so 7 times n is 7n, 7 times 9 is positive 63, and everything else has to come down. I'm not going to forget about this positive 10 here. Now, as a note, we cannot do 10 plus 7 first. Order of operations says that we multiply first, so we multiply that 7 with everything that's on the inside. Okay? Don't do 10 plus 7 to get 17. Alright, next step here is I'm going to look for like terms, and I notice that 10 and 63 are constants, and I'm going to combine those to get 73, and I'm going to bring down everything else. And now I'm going to make a decision because I see that there's an n on the left and an n on the right, and I only want it on one side. So I'm going to draw my river, and I'm going to get rid of 7n here. So the opposite of plus 7n is minus 7n. I'm going to do it to the right side, and I'm going to bring that over to where the other n is because they're like terms. So these cancel out. I'm left with 73 is equal to 51 plus 2n. 9n, take away 7n is 2n. In my next step, I need to get this 2n by itself, so I've got to subtract this 51. I have to get it out of there. And if I do it to the right side, I got to do it to the left side. Always balance your equation. So now I'm going to do my math. 73 take away 51 is 22. These guys cancel out. I'm left with 2n on the other side. And my last step is I've got to do the opposite of multiplying by 2. I'm multiplying by my coefficient, so I've got to divide by 2 on both sides. These n's cancel out. I'm left with 11 is equal to n. 22 divided by 2 is 11, and bring down your n. That's your final answer. Let's go to our last problem. All right, here we have a problem where we have to determine whether we have no solution, infinitely many solutions, or one solution. So I'm going to look at my equation. I'm going to draw my river, and I notice that I have like terms, so I have to combine them. Negative 6x plus 6x gives me a 0. They cancel out. They do not just give me x, and I'll really quickly explain why. Let's look at 6x. That tells us that I have 6 x's. If I remove 6 x's, that means that I'm getting rid of this one, 2, 3, 4, 5, 6, and I'm left with 0. Okay, so that's one way of looking at it. So this left side gives me 0. I'm going to bring down my other side, which is negative 1. And I'm going to ask myself, is this a true statement? Is 0 equal to negative 1? It is not equal to negative 1. This is not a true statement. So we say that there is no solution. No solution. All right, let's go on. Here I have an equation. I'm going to draw my river. I'm going to notice that I have a 6x and a negative 6x on the same side, so those I can combine very easily. That gives me 0x. They actually cancel out, so they're gone. Bye-bye. So I'm going to bring down my 3 is equal to 3, and is that true? 3 is equal to 3. That is a true statement, and what that tells me is that I have infinitely many solutions. Infinitely many solutions. Meaning any number that I replace inside of my equation for x will make the equation true. If I put in 3, it will be true. If I put in 100, it will be true. If I put in 0, it will be a true statement. All right, example here. Now again, I noticed automatically I see a number outside of parentheses, so we should be very comfortable distributing. 4 times 2x is 8x. 4 times 1 is a positive 4, and I'm going to bring down everything on the other side. All right, so my left side looks good. On my right side, I notice that I've got like terms, 5x plus 3x. I can combine those. 5x plus 3x is 8x plus 4, and on the other side I've got 8x plus 4. And what we learned in class is that when we have a situation where we have the same coefficient, in this case 8, and the same constant, in this case 4, I again have a situation where I have infinitely many solutions. And let's prove that. So I got to get my variables on one side and my constants on the other. So let's start with subtracting 4 from both sides. These are gone. I'm left with 8x is equal to 8x. Now I've got to get rid of my variables and get them on one side. So I'm going to subtract 8x. And these are gone. I'm left with 0. 8x take away 8x is 0. So 0 is equal to 0. That's a true statement. That supports this conclusion that I have infinitely many solutions. Finally, we are at our last problem, I think. What we are going to do is again distribute because I see a 6 outside of parentheses. 6 times x is 6x. 6 times negative 1 is negative 6 is equal to the other side, negative 5 plus 6x. There's nothing I can do there. All right, so now I've got some decisions to make. I'm going to draw my river, and I've got to get my variables on one side and my constants on the other. Now, before I do that, I just want to notice that I have the same coefficient, but I have different constants. This is a -6 and this is a -5. When I have the same coefficient and different constant, that tells me I'm going to have no solution. Right? I have the same coefficient, but I have different constants. I think that's similar to our first example that in this section. So let's just prove that conclusion. So let's say I want to get rid of this -6. So I'm going to add 6 to both sides. These guys are gone. I'm left with 6x is equal to -5 plus 6 gives me 1 plus 6x. And I want to get my variables on one side, so let's get rid of this 6x and this 6x over here. These cancel out. I get 0 is equal to 1. And that is not a true statement. That is why I have no solution. Alright guys, that is the end of this video. I hope that this is helpful for you. Make sure that you're prepared for Mondays. If you have any questions, please feel free to email me. My email address, I'll give it to you again, is sdrozd@metropolitanels. You can contact me there. Good luck and I'll see you soon.